What's up guys, welcome back to a new video. In this session we are going to be solving exercises on derivatives where you have to use fractions. I will be going through several exercises step by step, explaining everything I do along the way. As always, these exercises start out very basic, but will get progressively more complex along the way, so feel free to skip around according to your own level. The timestamps of each exercise can be found in the comments or the description below. Before we go into the first exercise, I want to take a few seconds to explain this general formula which you'll have to use to solve these exercises. If you have the derivative of f of x divided by g of x, the way you solve it is by writing this fraction. So first you write g of x, leaving it unaltered, and taking the derivative of f of x. Then minus f of x, so you leave f unaltered, and you take the derivative of g of x. And you divide these two terms by g of x squared. Because this is quite a mouthful, I always remember this complicated formula by just saying g df minus f dg divided by g squared. With that general theory out of the way, let's go to the exercises to see how this works into practice. The first exercise is the derivative of 1 over x. And you might now immediately object, well, I know what the derivative of 1 over x is without using fractions, but this is just an exercise to see how the formula works. And well, if you know the derivative by heart, then you can quite easily check whether the formula actually has the right result or not. The first step of all of these exercises is to identify f of x and g of x. So f of x is the function in the enumerator. In this case, it's just 1. It's just a constant. The second is g of x, which is the function in the denominator and which is just x. So now we can use our general formula, which says that the derivative of f of x, which is 1, divided by g of x, which is x, is equal to g df minus f dg divided by g squared. So we first leave g unaltered, which is x, and we derive our first function. Then we leave our f of x, our first function, unaltered, and we derive our g of x, which is x. And we divide by g squared, and g squared is in this case x squared. Let me rewrite this. So we have x times the derivative of a constant is 0, so times 0, minus 1 times the derivative of x is equal to 1, divided by x squared. This is of course equal to minus 1 divided by x squared. And this is our result already. And of course, we know that this is correct because, as you said already, you know what the derivative of 1 over x is. But this just as a basic introductory exercise. The next exercise will be a bit more complicated and you will not know the derivative by heart, which is 1 divided by the cosine of x. The first step, as always, is identifying f of x and g of x. F of x is the function in the enumerator, which in this case again is 1. G of x is the function in the denominator, and in this case that's cosine of x. And now we can use our formula. As a reminder, I will write out now, which is g df minus f dg divided by g squared. Let's fill this in for our example. G is cosine of x. Df means we have to take the derivative of our f function, which is a function in the enumerator, which is 1 in our case, minus f, which is just 1, times the derivative of the function in the denominator, which is cosine of x. And we divide this entire thing by g squared, which is the cosine of x squared. Let's see what this gives. So it's the cosine of x times the derivative of 1 is 0, minus 1 times the derivative of the cosine of x, which is minus the sine of x. And here you always have to be careful that you don't forget this minus sign. And you divide this by cosine of x squared. Rewriting this, we get 0 minus sine of x divided by cosine squared of x. And this is simply equal to sine of x divided by cosine squared of x. And there we already have our result. So this was the derivative of 1 over the cosine of x. This is going quite well. So let's go to another exercise. In this exercise, we're going to be deriving sine of x divided by the cosine of x. And again, here you will object, wait a minute, I know what this derivative is already, because sine of x divided by cosine of x is just the tangent of x. And I know the derivative of the tangent of x. It's just 1 divided by the cosine of x squared. And yes, that's correct. But let's see how we can get that result if we for some reason forgot what the derivative of the tangent of x was. First step is again to find f of x, which in this case is not 1, but it is sine of x. And what is our g of x? Well, it's a function in the denominator, and that's just cosine of x. This can be used in our formula again, which is g df minus f dg divided by g squared. And I will be saying this a lot, so don't worry, at the end of this session, you will remember this formula. Let's fill this in. G df means g, which is the cosine of x, times the derivative of f, and f is the sine of x, minus f, which is the sine of x, times the derivative of the cosine of x, which is g in this case. And we divide this entire thing by g squared, which is cosine of x squared. Let's rewrite this. Let's do these basic derivatives. So we get cosine of x times cosine of x, because the derivative of the sine of x is the cosine of x, minus the sine of x times, and here again we should not forget this minus sign, minus the sine of x, because the derivative of the cosine is minus the sine of x. And we derive this by the cosine squared of x. Rewriting this further, we simply get cosine squared of x plus, because this minus sign and this minus sign becomes a plus, sine squared of x divided by cosine squared of x is just equal to 1 divided by cosine squared of x, because here we used that cosine squared plus sine squared is simply 1. It's this basic formula, the most basic formula of geometry. So we have our answer, which is here. And we already knew this because we know that d over dx of the tangent of x is indeed 1 over the cosine squared of x. This is going very well. So let's now step it up a bit and do a derivative of which we don't know the answer beforehand. We're going to look at d over dx of tangent of x divided by x. And here I have to note that in a previous video where we did derivatives of products of functions, we already solved this derivative, because we can write this as tangent of x times 1 over x. And then we could just use the formula for the product of functions. However, in this case, we're not going to do it this way. We're going to use the formula for the fraction of functions. As always, we start by identifying our two functions, and f of x in this case is the tangent of x. And g of x, our function in the denominator, is in this case simply x. And again, then we can use this as GDF minus FDG divided by G squared. And let's just fill this in. So GDF means G, which is x times d over dx of f, and f is simply the tangent of x, minus FDG, so f is tangent of x, dg is d over dx of simply x, and we divide this entire thing by g squared, which is now simply x squared. Rewriting this, we get x times 1 over the cosine squared of x, which we proved in the previous exercise, minus the tangent of x times the derivative of x is simply 1. That's great. So divided by x squared. And if we rewrite this, we get x divided by cosine square of x minus the tangent of x divided by x squared. And now we have this somewhat ugly function, so we can just rewrite it for aesthetics only. So we get x divided by x squared times cosine squared of x, which is just this x squared into this denominator, minus tangent of x divided by x squared. So what I did here is just cut this division, this fraction up into two parts. This one goes there, and it also goes into that one. And we see that we can cancel this x with 1 power of x here. So our final result is 1 over x times the cosine squared of x minus the tangent of x divided by x squared. And if you know or remember, this is exactly the result of the previous video where we solved the same equation or the same exercise, but with the rule of multiplication. Let's go to the next exercise, which is a bit more difficult. We have d over dx, so the derivative of a fraction of functions, the ln of x plus 1 divided by the square root of x. This derivative cannot be solved in any other way than using the formula that we're using here of fraction of functions. The first step, again, is identifying our two functions. So we have f of x is a function in the numerator, which is ln of x plus 1. And g of x is the function in the denominator, which is just the square root of x. And then again, we can use our formula, which is gdf minus FDG divided by g squared. And let's fill this in. We have GDF, which is the square root of x times d over dx of the ln of x plus 1. And you already see this is going to become a lengthy expression, so bear with me. Minus f, which is ln of x plus 1, times d over dx of our other function, which is the square root of x. And we divide this entire thing by g squared, which is the square root of x squared. And we of course know that this is already just x, but well, we'll leave that for the next step. Writing this out, so taking these basic derivatives, we have the square root of x times 1 over x, because the derivative of ln of x plus 1 is just the derivative of ln of x, because the derivative of 1 is 0, and the derivative of ln of x is just 1 over x. Minus, now we get to this term, so we get minus ln of x plus 1 times the derivative of square root of x, which is simply 1 over 2 times the square root of x. And we divide this all by x, because we knew that this square root of x to the power of 2 is just x. So our derivatives part is over. So let's now just rewrite this. So we have the square root of x divided by x. Let's see what this actually means. So the square root of x divided by x is equal to x to the power of 1/2 divided by x. This is just equal to x to the power of 1/2 minus 1. And this is just equal to x to the power of minus 1/2 is 1 over square root of x. So we see that square root of x divided by x is 1 over the square root of x. And if you're confused by this step here, I simply use that 1 over x is equal to x to the power of minus 1. But I guess you already knew this. So we can, well, just as well rewrite this first term, because we already know that the square root of x divided by x is equal to 1 over the square root of x minus ln of x plus 1 times 1 over 2 times the square root of x divided by x. Let's see what this becomes. So we get 1 over the square root of x minus ln of x divided by 2 times the square root of x minus 1 over 2 times the square root of x. And what I did here is just multiply this ln with this 1 over 2 square root of x and then multiply this 1 with the same term. And we divide this all by x. Because all of these terms have a, well, semi-common denominator, we can just multiply by 2 here and here, so we didn't do anything. We can drop this denominator to the other common denominator, which means that we get 2 minus ln of x minus 1 divided by 2 times the square root of x times x. And again, what I did here is drop this common denominator to this large denominator here. And this x just remains here. And we can rewrite this again. We see that we have a 2 minus 1, which just becomes 1. So we have 1 minus the ln of x divided by 2 times. And now we get some other expression of x. So we have the square root of x times x, which is x to the power of 1/2 times x to the power of 1, which is x to the power of 1/2 plus 1, which is x to the power of 3/2. So we get here x to the power of 3/2. And this is our result. This is our actual result of, well, lest we forget, the derivative of ln of x plus 1 divided by the square root of x. So this is our result. Let's go to the last and final exercise, which is actually a function that is often used in physics, in, well, more advanced physics. And actually, it's also used in training neural networks. So we get e to the power of x plus 1 divided by e to the power of x minus 1. Again, the first step is to identify our functions. So f of x is equal to e to the power of x plus 1, which is the function in the enumerator, and g of x, which is e to the power of x minus 1. And for one last time, we can write our general formula, which is gdf minus fdg divided by g squared. And we can fill this in, of course. So we get gdf. G is e to the power of x minus 1 times df, so d over dx of e to the power of x plus 1, minus e to the power of x plus 1 times g times d over dx of g, which is e to the power of x minus 1. And we divide this entire thing by e to the power of x minus 1 squared, because g squared and g is e to the power of x minus 1. Taking the derivatives, we have e to the power of x minus 1, d of e to the power of x plus 1 is d over dx of e to the power of x, which is simply the same again, so is e to the power of x, minus e to the power of x plus 1, which is just this term, times the derivative of e to the power of x minus 1 is equal to the derivative of e to the power of x. And that's just, again, e to the power of x. And we divide this entire thing by e to the power of x minus 1 squared. The next step is to calculate out these brackets. So we have this term times that term, and then this term and that term, which we get e to the power of x times e to the power of x minus e to the power of x, which is this first term, minus e to the power of x e to the power of x minus e to the power of x. And this last minus is because we have e to the power of x, but this minus sign is important. Divided by e to the power of x minus 1 squared. And then finally, we see that this term and this term drops out, and we get minus 2 times e to the power of x divided by e to the power of x minus 1 squared. And this is our result for our initial derivative. This brings us to the end of this session, and I really hoped that you learned something. If something was confusing or you have any remarks, just let me know in the comments down below. I read all of them and I respond to all of them. If you have some suggestion for future topics, you can always comment down below, and you can be sure that I will make a video on that topic. If you liked the video, and as a matter of fact my other videos, just drop it a like, because then it is more likely that other people trying to find material on these topics will find my videos. If you want to get notified for future videos, you can always just subscribe. And with that, I see you guys in the next video. Bye.